Hello everyone. So in our last class we have discussed that in the Gauss legendary quadrature formula, so if you substitute n equal to 1 there, then you will get basically trapezoidal rule, right? This one for n equal to 1. So what is this formula? You can check. This is your final formula for the integration I. Okay, this value you are getting this, right, for n equal to 1. Now if you substitute n equal to 2, okay, then basically you have to take up to this term, right? Because whenever n equal to 1, then this have no role, but n equal to 2 you have to take this thing. So if you substitute n equal to 2, so what you will get? Okay, so I am copying this for your better understanding. Okay, so this will become Simpson one-third rule. You can write 1/3 also, no issue. Okay, Simpson one-third rule. So this is basically 3-point quadrature, or you can say this will be n equal to 2. So consider n equal to 2 in Gauss the quadrature formula. If you substitute, so you will get, I am writing this with IS notation, S for Simpson. So this will become h into 2y0 plus 4/2 delta y0, that means your y1 minus y0, plus 8/6 minus 2 right, eight by 6 minus 2. Sorry, there is a mistake. Basically here you see this is u/2, right? If you do integration of that, so basically you will get u square by 4. Okay, that's why this will be 4. Okay, so this formula is actually n square by 4 this term. That's right, there is some calculation mistake. Anyway, so this is actually 4, so this will become 1, right, into delta square y0. Delta square y0, I think earlier we have done, this is actually y2 minus 2y0 into y1 plus y0, right? So this type, or you can do using that delta y1 minus delta y0. Sorry, this is, yeah, delta y1 minus, and then substitute the value of delta y1 minus y0, right? So y2 minus y0 this term. In this way you will get this thing. So 2y0 plus 2y1 minus y0 plus, this is, you have so 2/6, that means 1/3 y2 minus 2y1 plus y0, right? So you see this cancel, so 2y1, okay, and 1/3. So if you take common 1/3 here, so basically this will become 6, right? So 6y1 plus y2 minus 2. Therefore you are getting y2 plus 4y1 plus y2. So better to write this is y0, this is y2. Okay, so this is your new formula. This is called the Simpson 1/3 rule. Okay, is called okay. Now remember, this is 2-point quadrature, so whenever you are dividing your interval, that must be a 2-point, like suppose you are doing here to here, right? So basically you are taking 2 points in this way. Okay, so number of interval for the simple one it will be 2 and no issue, but whenever you are using this thing with composite one, like in trapezoidal we have done, right, that you are breaking that integration in several parts. In each part you are applying that formula. So if you do that one, so remember there that number must be even. Okay, so this is done. Now here also you can do the error part. Okay, so this error part is your home task. This is a similar way. Okay, I just guide you. So you write properly in your note. So ES will be what? A to B fx dx minus is, right? Now here basically this is your x0 to x0 plus 2h, right? Fx dx, because you have this is 3-point quadrature n equal to 2, and this is already you got basically f of x0 plus f of x0 plus h, sorry this is 4, plus f of x0 plus 2h. Okay, this is you got. Now again this part whenever you are considering, so assume that you have a function f for which f dash x is your fx, right? So if you substitute that f dash x, so this will become f of x0 plus 2h minus f of x0, right? Then break this using your Taylor's theorem and you get some expression. Okay, now for the next part you break this f of x0 plus h and x0 plus 2h in using Taylor's theorem. Then you substitute all the value and collect the what are the term you are getting. So finally you will get your ES will be minus h to the power 5 f4 j by 2880. Okay, so you write this properly. So this is your homework 2. This is not difficult, but you have to do very carefully, because this number already you are saying that 2880 this type of calculation. So don't do any calculation mistake and take help from the book. Okay, So this is your error. Now we are going to the composite case. Okay, so if you divide your interval in 2m part, to a sub interval, that means what will be the number of point? That will be actually 2m plus 1 point, right? For example, if you break in 2 sub intervals, so there are actually 3 points, right? So similarly, if you break in 2m part, so there will be 2m plus 1 point. Okay, so with nodes x0 plus h, x0 plus 2h, and dot dot dot, basically x0 plus 2m minus 1 h, okay, this way you are collecting all the term. So we can write from the last one, this is maybe 2m minus 2, we can write x0 plus 2m minus 1 h, x0 plus 2m h. So this is your actually A, right? And this is your actually B. Okay. So what you are getting, so if you applying this composite, already you have seen we are writing C here, right? So this is 3-point quadrature, so x0 to x0 plus 2h f of x dx, right, plus x0 plus 2h to x0 plus 4h fx dx, plus so on x0 plus 4h to x0 plus 6h. Sorry, last one we are just writing on it. So this will be 2m minus 2h to x0 plus 2m h fx dx. Okay, so each one you are applying the Simpson formula. So h by 3, you can take this is common for all the one. So from the first one you will get f of x0 plus f of x0 plus h, that means we can write in terms of x1. So this is will be your x1. Yeah, so basically your xi equal to x0 plus ih, that you know, right? So from there you can say this is your f of x1, sorry, this will be 4 plus f of x2. This is for the first one. So similarly if you do for the next one, this will be f of x2 plus 4 f of x3 plus f of x4, right? Similarly for the next one, if you do, that will be, can you say what will be a term? That will be for your 4 to 6, right? So it will be f of x4 plus 4 f of x5 plus f of x6 in this way, right? So the last term will be your, for the last integration it will be f of x0, sorry, 2m minus 2 h plus 4 times f of x 2m minus 1, why I am writing h, sorry, this one, plus f of x of 2m, right? So this is done. Now you just see what are the term you are getting. Basically all the odd power, you see the coefficient is 4, right? And all the even power, basically the middle one, this f of xt, f of x2, this is appearing 2 times, right? Similarly you will see f of x4 will appear 2 times, but the first and end, that even number is appearing only once. So basically in terms of, if you write y I equal to your f of xi, so then this formula becomes h by 3 y0 plus 4 y1 plus okay, I am writing one second, or you can write directly. This term is already we have written. This term you are writing y2m plus 4 common y1 plus y3 dot dot dot, you have y2m minus 1, right, plus 2 times y2 plus y4 plus dot 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 y2m minus 2, right? So this is your formula. So you can write this is your h by 3 plus sum of first and last ordinate plus 4 times sum of all odd ordinate plus 2 times sum of all even ordinate except boundary. That means except for the first and last ordinate. Okay, so in this way you are getting. So this is your formula, similar to your trapezoidal one. So already you have done the homework for the trapezoidal. Similar thing you have to do here again. You have to make a table. So after that you have to just write the formula. So these are very easy. And if you say what are the error, so overall error will be your minus b by a whole to the power 5 by 2880 f for xi, where xi lies between a less or equal to xi less or equal to b. Okay, so this is your formula. Yeah, so like if this problem is asked to do using your Simpson one-third rule. Okay, so remember that number of interval must be even. Here like they have provided that do in 6 sub interval, that must be even, then only you can apply the Simpson one-third rule. But for the trapezoidal one there is no restriction, you can easily apply. Okay, so after that just use this formula and you got your answer, and it will be better than your trapezoidal one. You will get lesser error. Okay, so basically already you have seen that trapezoidal one fit with that trapezoid, right? But actually the Simpson 1/3 rule, this is approximate using your some parabola, because this is 2-point quadrature. Okay, so basically if you have some function, okay, suppose you have some function like that. So suppose you have 1 point here, this point here, and you have to take one more point something here. Okay, so this is your y equal to fx. Okay, so basically Simpson 1/3 do they are trying to fit a parabola inside this three, using your this 3 point trapezoidal. You have seen that there is some straight line, right? Like in trapezoidal you have seen this is like some anyway, this is not the proper one. Suppose you have some function according to the book. If I draw, this will be like they have considered this type of thing. Suppose you have 1 point here, 1 point here, okay, and 1 point here, equal distance. So basically they are trying to fit some parabola here. Okay, maybe this point is this type. Okay, basically in trapezoidal this is like they are trying to do in this way. So this is trapezoidal. Okay, and red one is for your Simpson. So you can see so beta area will provided by that red one, right? Because what will be the area is your this much, right? This is the area portion. So red one is more close to your actual blue one. So that's why this is more good if you apply the Simpson 1/3 rule. Okay, so this is your quadrature last one. Okay, we have one more thing, that is Newton Cotes formula that you have to do. Now I am giving you a homework to practice this Simpson 1/3. So your homework 3 is, let me check, evaluate zero to pi by 2 or root cos x dx by Simpson 1/3 rule using n equal to 6. Okay. Correct up to three significant figure. Okay, so this is your Simpson wanted one. Okay, so I give you one more lecture on the Newton Cotes formula. Okay, bye for now.